Okay, now that we've established loosely how our game is going to play and what the general idea of our game is going to be, this image is our refresher here. We're going to basically make a 3D game with a player spaceship thingy that can move from left to right using the arrow keys, and there will be an onslaught of meteors coming toward the player and consequently toward the screen a little bit because of the angle that I plan on putting the camera. And that'll basically be the entire game. You'll move from side to side and dodge the meteors. So nothing too complicated. We're going to begin making the game. We're going to jump right into coding the game. And you may think, well, don't we need to create some graphics first? And no, what we're going to do is use Dart Basic. Dart Basic has command lines built into the language that allow you to create primitives or very general 3D objects like spheres and cubes and things like that. And I always like to kind of flesh out my idea using that functionality before investing all of the time and effort into creating a lot of graphics. The thought process simply being that there have been times when I have prioritized the graphics first, only to find out once I got the game actually coded that it wasn't fun. It wasn't as entertaining as I envisioned it. And now I had invested all this time and effort into creating graphics that I had no use for, anymore at that point. So I'm going to quickly work up a working version of the game using nothing but Dart Basic Professional, and then from there we will go back and create the graphics and replace the primitives within the code with those graphics that we create. So that's how we're going to approach this. I've loaded up Dart Basic Professional, and let's see, I'm going to name my project Space Game. All right, so here we go. So first thing we're going to do is we're going to turn sync on. Now, if you type a command that Dart Basic recognizes, something that's built into the language, a couple of things you'll notice. The text will turn blue, and down here you will get an indication of what the syntax for that command is. You see sync on and then no parameters, meaning that this is complete. You don't follow this with any parameters to use in this command. If you hit F1 on your keyboard, you bring up the help, and it's context sensitive. So if your cursor is within this sync on verbiage, it knows that you're looking up that command. And basically what this does is it allows you to take control over the refreshing of the screen in your video game. So basically the screen will refresh when and only when I tell it to. And we will put that command, the command for the screen to actually refresh, within our do loop portion of our code. You'll see that in a moment. But we're going to take control of the syncing. Then we are going to lock the sync rate. And that is where we will basically cap the frames per second of our game. And that's kind of important because my system is pretty robust, and this game is going to not be. So if we didn't throttle the frames per second, it would probably run so hella fast that the game wouldn't be playable. And then if we put this game on another machine that didn't quite have the system specs of mine, we would just have a lot of inconsistency in the experience of the game. So I'm going to cap it at 60. Any modern computer will be able to run this game at 60 frames a second, no problem. So we have that. Then I'm going to turn AutoCam off. AutoCam is another inbuilt command into Dart Basic, and basically what it does is if AutoCam is on, which it is by default, anytime you create a 3D object, within Dark Basic, the camera basically snaps to that object, meaning that the camera will move, it will physically move to wherever that object is and basically zoom out far enough so that you can see that object on the screen. So we want to take control of the camera. We don't want it bouncing around on its own whenever we create objects. So I'm going to turn that off so that the camera will not move unless I tell it to do so, unless I update its coordinates. So there you go. Okay, so now we just kind of have to think our way through this, and this is part of programming here. It's almost like a game unto itself, as I mentioned earlier. We have got to really plan and kind of just go back and forth and figure this thing out. So let's think. We're going to need some meteors. Let's build the meteors first, and then we will build the player ship afterward. And let's see, we'll need meteors, we'll need a player ship. Eventually, we will probably need 1 or 2 planes, which are just huge, flat polygons, like huge squares that are completely flat. Though we'll probably use those for our backgrounds, something to put in the background that we can put a texture on, create background effects on. But save for that, those are really the only 3D objects that we're going to need at this point. Okay, so let's think. Let's make a variable called num meteors. That's my son talking in the background. Num meteors equals 10. Okay. Now the reason we're doing this is because we are going to say for a equals 1 to num meteors. Now that may look really complicated. What we're doing is we're creating what's called a for next loop. Rather than writing code that says, hey, create meteor 1, now create meteor 2, now create meteor 3. And you got to think, we're not just creating them, we're going to be creating them and then doing some things with them. We're going to be sizing them, we're going to be texturing them, we're going to be positioning them. And unless you want to write or copy and paste that entire section of code over and over and over for every meteor, we can do this a little more intelligently. We're going to create a for next loop that basically steps through the same code X number of times, and the variable here that I've used for this is going to auto increment every time the code loops. So the first time around, A is going to equal 1. The next time around, A is going to equal 2, and then 3, and then 4, all the way up to whatever num meteors equals, which is 10. So for A equals 1 to num meteors, let's make object sphere, which is another inbuilt command. You can see it turn blue. Now notice down here at the bottom, it's telling me what parameters I can use with this command. Make object sphere object number size rows columns. I can do either syntax. We don't need the rows and columns. I'm just going to do the object number and the size. Now the object number is going to be A, and the size is going to be 20. I don't know the scale of our world at this point, but we'll start with 20, just as an arbitrary number, honestly. So what happens here is we are making object sphere, which again is an inbuilt command, creates a 3D object from a sphere mesh. And every time this line executes, it is going to make an object called sphere, and A is going to be the number of that object. So the first time this code executes, it's going to say make object sphere 1, because A equals 1 the first time around. Second time around, make object sphere 2, all the way up to 10, because that's what num meteors equals. And make each of these the size 20. Okay. Now, next A basically completes the for next loop. So for A equals 1 through 10, which is the number of meteors, make object sphere 1, 2, 3, 4, 5, all the way up to 10, make them all size 20, and that's it. Loop this until A equals 10, and then it moves on. That's it. Okay. So let's go ahead and see the result of that. I'm going to go ahead and build my do loop. I'll explain what this is. Okay. This is where the main portion of our game is going to live. All this up here is basically going to be initialization. This is going to be where we create our objects, we declare our variables, we set things up, we set the stage, and then between this do and loop, this is just going to run constantly, constantly, constantly. That's going to be the actual video game playing. So we want to do a bunch of stuff, update the screen, and then loop it all over again. That's what this is going to do. Okay, so if we were to run this code right now, and I'm going to do so by pressing F5 on my keyboard, or you can click this right here. Basically what you see is nothing. Now why don't we see the square, the meteors, the spheres that we created? Well, we don't see them because we turned auto cam off, which means our camera is actually inside of our spheres. By default, the surface of the spheres, only the outside surfaces of those render. Now you have the ability to affect objects. Leave it as a call flag to toggle that so that you can see the inside of objects, but by default it's off. So we're just looking basically inside the sphere and looking outward and looking right through the walls of the sphere. Now see, if I were to go up here and turn this off, or rather turn it on, turn auto cam off, and I'm going to do that. This is something else that's you can learn here. I'm going to do that by typing rem space before that line, and you notice how it graded out. Basically what that does is it turns that line into a comment, which basically is just a way the code it skips that line when it compiles and runs. So you can use a rem to do things like make yourself notes. This is where my setup code is. This is the game's main loop. And that's a great way of making, of having documentation in your code so that you can remember what certain bits did, why you did things certain ways, what certain variables mean, etc. But we're going to use it in this case just to nullify that command. And now look what happens. You see our spheres. Now, it looks like only one sphere, but that's because we created them all in the same exact spot. So we have 10 spheres that are kind of overlapping each other. But there they are. I'm going to turn auto cam back off, and we'll control the camera ourselves. But let's go back up and play with this bit some more. Let's position these spheres at different random locations, so they're not all on top of each other like that. You know, we could do this by simply typing in the command to position the sphere at different variables, or we're actually going to use a randomization variable. But I want to be a little bit smarter about it because I know these objects are going to be moving later in our game. So here's how we're going to do this. We are going to use something called an array, or actually a few arrays. A variable like this num meteors. A variable is like a box that contains a value. An array is like a bigger box with many smaller boxes inside of it, each of those smaller boxes containing the value. So if a variable is like a box, then an array is like a bigger box that you're putting all of those little boxes inside. Best way I can think of to explain it. The way you declare an array in Dark Basic Professional is you type in dim, declare your variable. I'm going to call it, I'm going to say me your x, And then we got to tell it inside this bigger box how many smaller boxes to put. And we needed one smaller box for every meteor that we have. So rather than typing in 10, because we have 10 meteors, I'm going to put in num meteors. Now why am I doing that? This is something that's important to address. If we ever decided that we wanted 5 or 20 or 100 meteors, we would have to go, if we didn't do it this way, we would have to go throughout our entire code and find everywhere where we reference these meteors and change the code to account for 100 or 20 or however many we change it to. But if we declare a variable called num meteors or whatever, and we declare how many meteors there are here, and instead of using 10 throughout our code, we simply reference that variable, which equals 10 right now, then later, if we want to change the number of meteors, we simply change this one variable. See, now this array for meteor X equals, well, there's 100 small boxes instead of 10, because it's going to create however many boxes num meteors equals to, which now equals 100. This 4 next to it, now it's going to make 100 meteors because it's going to go for A equals 1, 2, num meteors, which now equals 100. So see, that's how you have to think ahead and create your program in a flexible way that allows you to expand in the future without having to rework too much. I'm going to turn this back down now. Okay, now I am going to call this meteor X with a pound sign so that I'm not having to use integers only. If I left it just like that, I couldn't use decimals. And I'm guessing that our meteors are the coordinates of our meteors, the speed of our meteors and things like that are probably going to require decimals, or else we're probably going to move too fast if we move them by whole numbers only. So I'm going to do that. I'm going to copy and paste, and I'm also going to make a variable for the z-axis of the meteors, because we want the meteors to be able to, we want to position the meteors at a random location on the x-axis, and we also want the meteors to be able to move on the z-axis, not up and down so much, but side to side and forward and backward. So then what I'm going to do is I'm going to randomize these values for every time this 4 next moves. I want to randomize the x and z coordinate of each meteor. And here's how I do that. Meteor x a equals, and the value. Now what am I doing here? I am saying take the meteor x, which is this variable, and which object am I wanting to, how can I say this? I'm wanting to declare the x coordinate of which object? Well, whatever a equals. That way I run this for every meteor that exists. The first time this runs through, we'll declare the x and z coordinates for meteor 1. The next time, meteor 2. You get the point. We are going to say random RND. That's how you randomize. And then we give random a range. So let's see, on the x-axis, we're going to say random, I don't know, we're just going to have to try something, 200. So what that'll do is that'll make meteor x of A equal a random number between 0 and 200. Okay, we'll leave it like that for now, but we'll come back to that. We're going to do the same thing for the z, except we need to put, we need to put the meteors far out into space so that we can see them coming toward us, right? So we're just going to put them all out there on an even distance away from the camera right now. We'll go 500 for now and see what that looks like. I'm not going to randomize that right now. I'm just going to put them out there and randomize them on the z-axis. So now that we've randomized on the x-axis rather. Now that we've randomized the x variable, the z variable, we now have to tell the program to position the objects at those coordinates. To do that, we will position object A at the randomized x coordinate, here x of A. 0 on the y-axis, we're not going to move the objects up and down in 3D space, but we are going to put them at a randomized position on the x-axis and at each of their respective z-axis coordinates, which for now will all be the same, all be 500. Okay, create objects 1 through 10, which are spheres, size 20. Randomize the x-axis variable for each object. Position the z-coordinate at 500, and then put the object at those positions. Loop that 10 times, and then enter our do loop. Let's see what that looks like. There they are. All 10 of them at a random x coordinate and pushed 500 units in 3D space away from the camera. Okay, we're going to go up here and put in another command called randomize timer. Now, what that does is it reseeds the random number generator. You'll find that if you keep using random commands in your program without reseeding the random number generator, you'll actually get the same sequence of random numbers over and over and over again. But redeclaring the seed and using the timer command will make it nearly truly random. So, so I'm going to do that so that these objects position in truly random fashion each time we run this. Okay, so that looks pretty good. Let's now something you will notice when we run this. In 3D space, 0. Okay, in 2D space, imagine my sphere. Imagine if this were a 2D video game. You don't have to worry about the z-axis, only the x and y, right? Point 0, 0 is right here in the top left-hand corner. If you want to go to coordinates 100, 100, you go over 100, down 100, and there's 100, 100, let's say. In 3D space, 0, 0, 0 is not up here. It's like here. We're standing on it. The camera is standing on it. It's the center of the universe, essentially, right? So we need to get a little creative with our x random number, with our randomization of the x coordinate here, because if it's randomizing between 0 and 200, it's always going to, all of our objects are always going to be left of right of our camera, right? So what we need to say is, okay, randomize it between 0 and 200, but check this out, minus 100. Think about what we just accomplished by doing that. Now, okay, imagine we're looking at we're looking in here. Okay, you can already see. All right. Before, let's say that this is right down the middle of our screen, splitting our camera here. Before, all of the meteors were randomizing from here and over, right? Because we were randomizing between 0 and 200. So they were all randomizing here, between here. Now we randomize still between 0 and 100, but whatever that equals, we're now subtracting 100 off of it. So if it equals 100, we're positioning it at 100 minus, or excuse me, at 0. We're positioning the meteor at 0 minus 100. So it goes over here. If it equals 200, the other extreme of the range that it can possibly land on, is going to equal 200 minus 100, or a positive 100. So now we sort of have a symmetrical range now, where the meteors can be randomly distributed between, rather than all being over here, we now still a 200 unit range, but shifted back 100 units so that it straddles the 0 line on the whatever axis. I'm tired. So anyway, you get the point. So if we need to make this range bigger, we can do that. If we needed to make this, say, 400, we can do that, and then we'll just shift it back 200, whatever's half of this amount. And all we'd be doing in that case is making this, instead of it being a 100 range, it would be or excuse me, 200 range, 100 on each side. It would be a 400 range, or 200 on each side. But what range we need to put that at will really depend on the positioning of our camera. So we'll figure all that out as we go. Let's see what that looks like. Yeah, cool. Okay, very good. Now let's make our player model. Do a little bit of cleanup here. All right. All right. I'm just doing some documentation here. Make player model. All right. Now let's make object. Let's make him a cube. And you can see down here the syntax, the object number and the size. Object number. Now it would be easy to say, well, we've used 1 through 10, so we make the player model number 11, right? Yeah, but what happens if we want to go back and change this number in the future? If we want to make 20 meteors or 100 meteors, right? 100 meteors would be very excessive, but realistically, we could make 20, right? So there's no rule that says we have to use up these numbers that are associated with our objects in any sort of chronological or successive order. We don't have to do that. So I'm going to make object cube 100. I'm very confident that I won't need 100 objects in this game. So I think 100 is an object is a number that's kind of isolated off to itself and won't interfere with any number of meteors I may want to use or any other objects in the game. So I'm going to make this cube object 100 in my game. And let's see, if I made the meteors 20, I'm going to make them 20 as well, let's just say. That's not in proportion, eventually the meteors will be bigger than the ship, but again, we're just getting something going here. So, we're going to leave him at 0, 0, which means we need to move our camera. All right. So let's, the camera isn't something that I plan on moving around. It's just going to be fixed. So I'm pretty comfortable rather than declaring X and Z and Y coordinates like this and then assigning them and doing all that. I'm pretty comfortable with just hard coding in where I want the camera to be. So I'm going to say position camera, let's see, X, 0, we don't want the camera moved side to side. Y, we do want it up in the air, suspended though. And we're just going to take a stab at this and see what it looks like. Say 200. And I want it kind of back some and looking down on the action. So let's say negative 400. So that puts our camera up in the air and back. Now that may be a terrible vantage point. We'll find out in a moment. But now let's point the camera, because as it stands right now, I'll show you. Yeah, see the camera's up in the air and back, but it's pointed straight out. So we want to sort of pivot it down. Point camera is an inbuilt command, and we want to point it basically, let's see what happens when we point it at our player. which is currently positioned on the 0, 0, 0 coordinates. Okay, not bad. I don't like our player in the middle of the screen like that. Let's not move the camera back as far. Okay, now we're kind of right on top of him, aren't we? Let's move him up a little bit. Okay, let's point the camera X, Y, a little bit deeper into the 3D world here. There we go. See, now we're making progress. Now we could take the time to in a more complicated game or in a bigger project. I actually would do this. We could actually code the ability to move the camera around and angle it and tilt it and that sort of thing, and make the coordinates and angle of rotation of the camera print to the screen. So that way we could just move the camera ourselves until we get it just right. You know, jot down those coordinates and then hard code them into the game, you know, once we find the angle and the position that we want. But in this small game, I'm just going to keep playing with the numbers until it looks right. And I think we're getting there, actually. Okay, so your player would be here on the screen, the meteors would be way out there in the distance coming toward you. Let's go with that for now. Let's go with that for now. Okay. Okay, yeah, not bad. I'm going to do something really quickly too. You can do this with code, but Dart Basic Professional has this handy little configuration menu over here where you can tell it to run windowed or full screen or whatever. Yeah, I'm going to do that. There we go. Okay, so we're not able to move yet, nothing's happening, but basically we have created our little 3D world here. We have our meteors out here, they're randomizing in position on the x-axis. They're at a fixed distance away from the player in the very beginning, but there's our player. So I think that's a pretty good place to conclude video 1 here. It's already gone on long enough, I'm sure. We will pick back up soon. We'll get some, get some movement going, start programming some of the actual game code itself, and we're going to do some interesting things with those meteors in terms of making them a little more varied. And once we get some gameplay mechanics going, we will start replacing these drab primitives with actual textured models that we are going to create. So I'm very excited about that. So look out for video 2. I will have it up shortly, and I will talk to you guys then. Bye.